Hi, everyone, and welcome to What's New in Earth Engine 2021, coming to you from our second year in a distributed virtual Geo for Good. I'm Emily Schechter, a product manager on the Earth Engine team, and I'm joined by other members of the Earth Engine team, Tyler, Joel, and David. We would like to tell you a little bit today about Earth Engine, but mostly focus on the improvements we've made recently based on feedback from you. Over the past year, we've heard about how you use Earth Engine in developer surveys and through partner interviews, and we've worked on improvements to the core workflows that you've told us about. We know you want more scalability, you want better interoperability with cloud tools, you spend time in the code editor, and you want more performant visualizations. So this year, we've set up our What's New in Earth Engine session as a lightning round of product updates in each of those areas. I'll tell you a little bit about Earth Engine and give you a couple of updates on our data catalog. Then we'll hear from Tyler, Joel, and David across a spectrum of product improvements. And finally, we're excited to welcome a special guest from the Group on Earth Observations, Yvonne Fong, to give you some updates on the GEO program that you heard about last year. So first, what is Earth Engine? Earth Engine is a cloud system for petabyte scale analysis of geospatial data with a vast archive of satellite imagery and other data sets, up to 50 petabytes now. And equally importantly, it has freely accessible computation capacity to do analysis at that scale. We manage the data and the computers so that you can focus on doing good science and translating that science into decision-making and impact in the real world. For an introduction to Earth Engine, please check out the Journey to Geo for Good training series on demand at earthoutreachonair.withgoogle.com. There are classes posted that will help you explore many common uses of Earth Engine, like analyzing imagery, animating imagery, and publishing an Earth Engine app. For the rest of this talk, we'll assume that you know basics about the Earth Engine product and focus on product updates from the last year. Now I'll start with some updates from our data catalog over the past year. Landsat Collection 2 is a major data reprocessing effort by USGS. Collection 2 Level 2, Surface Reflectance and Surface Temperature, is now available in Earth Engine, and Level 1 is on the way. Collection 2 Surface Reflectance now applies the most up-to-date science to Landsat imagery, and Surface Temperature is a new product that you can use in your analyses. We sped up the ingestion of Sentinel-1 and Landsat assets into Earth Engine, in particular the time for when assets are downloaded until they're available. So you should now see images appear in about 12 hours instead of 1.5 to 2 days. We're also working hard to be compliant with STAC standards. STAC is a geospatial standard that will allow you to query the catalog programmatically. We moved the catalog to STAC 1.0.0, and dataset providers can now supply a STAC config for dataset descriptions in the catalog. Here are a few of the many new datasets that we've added over the past year. We partnered with Planet to make high-resolution datasets from Norway's International Climate and Forest Initiative available in Earth Engine to enable a more accurate understanding of tropical forests. And you can check out Tara O'Shea from Planet's Lightning Talk later at Geo for Good to learn more. Google Research's Open Buildings dataset contains 516 million outlines of buildings in Africa derived from high-resolution 50-centimeter satellite imagery. Building footprints are useful for a range of important applications, from population estimation, urban planning, and humanitarian response to environmental and climate science. The Global Flood database provided by Cloud2Street contains maps of the extent and temporal distribution of 913 flood events occurring between 2000 and 2018 to create the first comprehensive satellite-based resource for global flood risk management and mitigation. You can learn more about these datasets and more in our data catalog documentation page. And now I'll hand it over to Tyler to talk about scalability improvements in Earth Engine.
Thanks, Emily. I'm Tyler Erickson, a developer advocate on the Earth Engine team. The Earth Engine platform is always evolving based on extensive feedback that we receive from the Earth Engine developer community. And scalability always comes up in the feedback. It's one of the things that developers love about our system, being able to interact with and analyze vast quantities of data across space and time. But they also point out workflows where they encounter scaling bottlenecks, limiting the amount of work that they can get done. So we're continually working at increasing the scalability of the platform. And in this section, I'm going to talk about scalability improvements for various aspects of Earth Engine that we've been rolling out. First, let's start talking about scalable storage for our data, especially raster data. As Emily described, Earth Engine has an extensive public data catalog containing petabytes of raster imagery. But it doesn't contain every raster that a user wants, so Earth Engine also provides ways for users to ingest their own raster data sets into Earth Engine's native storage. To provide developers with an additional scalable option for raster storage, last year at Geo for Good, we introduced the ability to use cloud-optimized GeoTIFFs, or COGs, stored in Google Cloud Storage. This is not only a highly scalable storage option, it provides additional flexibility for hybrid workflows involving other services and tools, such as Google Cloud Services. So a natural question to ask is, which storage should I use? To which I can clearly answer, it really depends. Our advice is, if you've been using the standard Earth Engine asset storage and you're happy with it, keep doing so, as it's slightly more performant. But if you need additional storage for large collections of rasters, or require the flexibility of accessing your raster data from other services outside of Earth Engine, try COGS on Google Cloud Storage. Let's talk about scaling up requests to the Earth Engine platform. Earth Engine can be the backend for many client applications, all with different purposes and needs. Until recently, we had a single endpoint through which requests were made to Earth Engine. This endpoint was optimized for low latency requests or low latency responses to requests, like those might come from an interactive web application. But recognizing that not all applications benefit from the same performance characteristics, we've introduced a second endpoint, which is optimized for throughput, which we call the high volume endpoint. You may benefit from switching to using this high volume endpoint if you're making a series of automated requests. For example, you might want to create a set of image chips for training a deep neural net model. By using the high volume endpoint, you'll be able to dial up the rate of requests further before encountering any errors that are related to request quota. You can find out more information about using the high volume endpoint in the Earth Engine docs. Now, let's talk about scalable visualizations. Earth Engine has always been a computational analysis tool to access and analyze large data volumes. But as developers build interactive applications on top of Earth Engine, rapid rendering of data is important too. Shown here is a screen recording visualizing the Hydroshed's free-flowing rivers dataset, a global dataset containing over 8 million river segments. We're zoomed into the Mekong Basin here, a relatively flat area of the globe with many rivers. In the past year, we have increased the speed of the rendering pipeline, but if you watch as the map is panned and zoomed, you will have seen some delays as the tiles are calculated. It's fast, but not fast enough. So we wanted to preview some new functionality that's not yet out, but it's coming soon. We've been working on a new way to style and visualize Earth Engine feature collections so that your analyses and your apps can be more scalable and interactive in the future. This new styling approach will be appropriate for vector datasets with fixed content, which can be optimized prior to use for fast rendering. You can see this on the right-hand side of the screen, comparing the old and new methods. This vector tile serving approach allows for thinning, complex styling, both of which can be applied on the fly. The tiles are served using Google Maps infrastructure and can scale up to millions of users. So look forward to that in the future. The next aspect of scaling that I want to talk about is joins. Joins are one of the key features of Earth Engine that enable users to take advantage of the plethora of Earth data that's available for analysis. Joins allow developers to relate and analyze disparate datasets. For example, you could relate changes in a vegetation index derived from optical imagery to the amount of precipitation derived from a weather dataset that occurred in a fixed number of days before the optical imagery was acquired. Among other things, this could let you explore the old saying, April showers bring May flowers, and see if it actually holds up, and where in the world it holds up, or see if this relationship has changed over the years. Beyond the changes that I've already highlighted in this section, we've made numerous small changes throughout the system, optimizing performance and reducing the occurrence of errors. And if you do receive an error, we're surfacing clearer error messages that can guide you to a potential solution. The final aspect of scaling that I want to talk about is in the context of the Earth Engine developer community. As I mentioned earlier, the Earth Engine community has been a major factor in guiding Earth Engine's evolution, and the vibrant community is one of the reasons that developers enjoy working with Earth Engine. Many members of the community have expertise, and they're willing to share that knowledge with others. They help in a variety of forms. We see experts that are participating in discussions about remote sensing analysis in the Earth Engine developers discussion group, or they're answering technical questions on GIX Stack Exchange. They're sharing links to scripts, papers, and application that might be of interest to others. And sometimes it's their own work that they're highlighting, but often it's raising the visibility of the work of others. Community members give talks, host meetups, curate data sets, write tutorials. They publish reusable code and modules and extension to make Earth Engine even more useful to others in the community. If you've been participating in the Earth Engine community, I'm guessing that some of the examples that I just listed off may have brought to mind names of others in the community that have helped you out. So I'm happy to announce the Google Developer Experts program, which currently spans 16 technology across Google and includes over 900 developer experts. It's being expanded to include a new technology category for Earth Engine experts. This program recognizes developers who are both experts in the technology and who are actively contributing to building their community. To become an expert, there's a multi-stage evaluation process, which is described on the Google GDE website. If this sounds interesting and you'd like to nominate a collaborative expert that you know in the Earth Engine community, let us know. Look for a post in the Earth Engine developers group for more details on how to nominate someone. So that's been a whirlwind tour of how we've been scaling up Earth Engine this year. But there's one more example of scaling that we've been working on, which I'm going to turn over to Joel to further describe.
I'm Joel Conkling, product manager on Earth Engine. One hypothesis that we have confirmed is that building powerful geospatial tools enables Earth Engine users to do great work. We are inspired and delighted on a regular basis by the ingenuity and spirit of discovery embodied by Earth Engine's community of users. And that community of users is healthy and growing. Geo for Good has never been bigger, and every month, Earth Engine has tens of thousands of active users, many of whom are helping each other in one of the highly active community forums. And yet, some potential users still have not been able to use it for their work. In the past, commercial and operational users of Earth Engine could evaluate the platform, but there was no clear path to long-term usage after evaluation. Now there is. We are so excited that Earth Engine is in preview with Google Cloud. Preview is a stage of the cloud product lifecycle that means a product or features are ready for testing by customers. This stage precedes general availability, which means that a product is ready for broad use. Companies and government agencies running operational workflows with Earth Engine can now build on Earth Engine for the long term. So in short, with this announcement, we're looking forward to supporting all sectors of society in achieving ambitious, science-based environmental sustainability goals. I also want to acknowledge that there have been concerns in this forum over the years about the possibility that Earth Engine would go commercial. So let's talk about what this means for non-commercial users. The headline is this: Earth Engine will continue to be available at no cost for nonprofit, academic, research, and educational use, just as it always has been. Earth Engine will continue to invest in impact-aligned features, datasets, and partnerships so that you, the Geo for Good community, can deliver on your potential. Earth Engine will also formalize a grants process for users to request additional resources to get their high-impact work done in a timely manner. As I said, we are continually delighted by the impactful work of the Earth Engine community. We are also really excited by the potential of commercial users to extend and expand that impact by putting the best that science has to offer into practice, all in service of a more sustainable future. To highlight an example, Unilever is using Earth Engine to deliver on its commitment to a deforestation-free supply chain for palm oil. Unilever is a leader in this effort and setting an example for many other companies. And a lot of that work relies on Earth Engine to map risks in their palm oil supply chain, which you can see an example of on this slide. So we've worked hard to ensure that this expansion of Earth Engine to commercial users is an improvement for the incredible Earth Engine community and for the entire planet. So here's a new hypothesis. Most of us are here because we want to make a positive difference in the world. Actually, that's not really the hypothesis. I have a ton of confidence in that statement. Here's the actual hypothesis. Making it easier for commercial and government organizations to translate science into action means that our work in this expanded community will be even more impactful. In fact, I believe it's going to be a self-reinforcing cycle where more research leads to more impact, and more impact leads to more research. I'm looking forward to seeing that play out. David?
Thank you, Emily, Tyler, and Joel for all those exciting new developments. I'm David Gibson, Earth Engine Tech Lead. Earth Engine gives you a platform of data, scalable compute, and Google Cloud integration. But there's more. I want to update you now on the tools that help you to conduct investigations using Earth Engine. We aim to get you high quality and actionable results more easily. There are a number of stops on the journey to results, and I'll cover all these in turn. Firstly, we aim to save you time getting started. To get going, you need documentation. Earth Engine has over 1,500 algorithms in its library, and we're ensuring that there are runnable examples for all of them. We're approaching 50% complete in this process now. We're building out further community tutorials where experts can provide detailed guides. These can now be Colab enabled so that you can run the full notebook yourself and build on it. In fact, the output in the tutorial is a live copy from the notebook, running on the latest code and data. There are many ways to use machine learning to classify land cover and identify phenomena of interest to you. We're aiming both to provide tools to make this easy and to provide ready-made datasets for common tasks. We are continuing to provide improvements to our machine learning tooling. We use the SMILE library to support random forest and per pixel classifications, and we're adding further support for temporal segmentation, such as BFAST. You may have been following along how the Cloud AI platform is growing into Vertex AI, and we will ensure that EE.model can take advantage of the new features there. Now, we're excited to announce that the dynamic world dataset that we talked about last year is available across the entire Sentinel-2 time range since 2017. This is a global 10-meter land cover classification. Agreement against expert consensus datasets exceeds other global classifications and competes with the best local models. Because it's continuously updated as Sentinel images are acquired, this opens up exciting new opportunities for change detection. See the lightning talk at this summit. Lastly, since the dynamic world produces a vector of probabilities per pixel, we're demonstrating ways to post-classify these using simple, rapidly trainable classifiers for your applications. Now, the Earth Engine Code Editor provides a portal into all Earth Engine's capabilities, and it's designed to make investigation easy and collaborative. You may have noticed an increasing number of layout changes and modernization of styling this past year. One of the more significant changes is our new Tasks UI, with more flexible ways to view task status, including a standalone page for when you have lots of exports to control. We'll be taking this kind of flexibility in how we set up the code editor interface and extending it further to provide new views into your work. As Joel has introduced, we're working with Google Cloud to bring more Earth Engine to more people. Even when working by yourself or in a small team, there are several advantages to using cloud projects in your work. The technical reason for this is so that we have better knowledge of where requests are coming from. You may have seen that apps already ask for a cloud project so that we can tell that it's your app and not you sending requests. But this also means you get to see a dashboard on the Cloud Console of the requests that your app has made. You could easily create or select a cloud project in the code editor. Cloud projects also let you select assets more easily. Instead of changing permissions on each asset in each folder individually, you can share a project with someone so that they can see everything in the project. Earth Engine Apps. We launched Earth Engine Apps 3 years ago as an easy way for you to publish results from the code editor. And in something of a Google tradition, apps have been marked as experimental as adoption was growing. At this point, we can clearly say that apps have reached the mainstream. Over 50,000 apps have been published, and they are used across a range of scientific, operational, and educational use cases. So as of this week, we're removing that experimental label to reflect our long-term support for apps. Additionally, we want to give you greater branding control of your apps to label it more clearly as your work and not Earth Engine's. Also, as of this week, you'll be able to upload a logo image which displays above the app. Here's an example from one of our partners. Okay, thank you for following along in this rapid tour of our evolving landscape. Through all these, from machine learning and algorithms to task and asset management to publishing, we're aiming to make a difference in how you manage your investigations so that you can make a difference in the world. Now I'd like to hand it over to Yvonne to tell you about the latest from the Group on Earth observations.
Hi, everyone. Very happy to be here. My name is Yvonne Fong, and I am a data scientist at EO Data Science, which is a consultancy with a focus on Earth observations and data science. We are also one of Google's partners onboarding users to Google Earth Engine. If you were at last year's summit, you would have heard of the Group on Earth Observations Google Earth Engine program, which has been running for a year and a bit now. So we thought that this would be a good time to give a quick update on what has been going on in this program. For those that haven't heard of it, the Group on Earth Observations Google Earth Engine program is supporting 32 projects across the world using open Earth observation data to tackle global challenges related to sustainable development goals, climate change, and disaster risk reduction. Last July, the winning projects were announced and awarded $3 million towards product licenses and $1 million in technical support from EO Data Science. These are all the countries where the program participants, including collaborators, are based. And you can see just how spread out everyone is across the world. There are many different organizations involved, mostly universities and government, but also intergovernmental organizations such as the UN, not-for-profit organizations, space agencies, and private companies. The 32 projects fall into 6 loosely defined themes: disaster management, biodiversity and climate change, water quality, land degradation, agriculture, and poverty alleviation. Although, of course, there are projects that are working to address challenges across these themes. So what has the first year looked like? All 32 projects were onboarded to Google Earth Engine as well as Google Cloud Platform, allowing for identity management and the use of Cloud Platform services. More than 2,000 hours of support have been provided to date, with 135 and counting support tickets resolved. We've held meetings with individual projects for some of the more pointy issues. Shout out to Noel Garlick from the Earth Engine team as well for supporting the projects and us, especially with some of the back-end buggy issues. The projects also had the opportunity to voice some of their feature and dataset requests to the team at Google, things they would like to see on the platform. We started out with a wide range of skill level and experience using Earth Engine across the program. So multiple training sessions were held to bring everyone to the same level so that they can effectively utilize the capabilities of Earth Engine. We also provided each project with $100 at the beginning so they can try out some of the Cloud Platform services. Later on, with Google support, the projects were able to apply for cloud credits on a case-by-case basis. On the marketing and communication side of things, our team has been working hard to communicate the science and the impact that is being created through this program through blogs, podcasts, and social media posts. A series of virtual meetups were also held last December for the projects to network and share knowledge, especially seeing that many of them are working across similar themes. These are the different training courses that were offered as part of the capacity building program, from foundations to advanced Earth Engine features, touching on machine learning, and also building Earth Engine apps. I just wanted to show you some of the publications and apps that have come out of the GeoGE projects, from algal bloom monitoring to mapping vulnerable communities, seagrass mapping, ice shelf monitoring, and forest land use change mapping. These are just a few examples, and there's significant impact coming out of every single one of these projects, made possible with Earth Engine's capability and the suite of Cloud Platform services. We have one more year to go, and I'm very excited to see more results and impact from this program. If you want to stay updated or find out more about what each of these projects are doing, Do follow EO Data Science on social media, check out the blogs and podcasts about the projects, or watch the virtual meetups that were held last December on our YouTube channel. That is the end of my short update. Thank you.
Thanks, Yvonne, for that recorded message. Wow, that was a real whirlwind of improvements and exciting project updates. Our roadmap of product improvements is informed by what we're hearing from you, and we want to keep hearing about your use cases and your bottlenecks using Earth Engine. So please join our Ask Me Anything session or our user research sessions later this week to let us know your questions and your ideas. Thanks for tuning in, and we'll see you later this week in future Geo for Good sessions. See you later.
Bye.
See you soon.
Cheers.